Hi, welcome back. So here, I didn't do this previously, but we can actually find the value of N1 and N2, right? If the weight here is actually 600, W is actually 600, we can actually say that the value of N1 should be 400, the value of N2 should be 200. And here, the value of N1 must be less than 200, value of N1 must be more than 200, must be more than 400. So let's say if the value of N2 here is 150, the value here must be 450, right? If we calculate this in, we can actually find that this value of F must be around 50. If we keep increasing the pedaling force, right, to maybe 100, these two forces must change in such a way that the difference between them will give you 300, because 100 times 3, 300 Newton meters of movement. Okay? So one of the possible values here will be 500. So how do you do that? There will be 500 times 1, such that 500 plus 100 is still 600. But 500 times 1 minus 100 times 2 is actually 300 newtons. Right? So this effect will still hold. If we increase this further to 150, right, or 200 maybe, what happens? You see clearly that this value here must become a 0 and this value must be 600. Which means that the front wheel has completely less contact with the ground. Okay? So with that, let's move on to the next topic, next part of pressure. Actually, in A levels, there's not much of difference of pressure from your O levels. For pressure in liquids, we know that the pressure is equals to the density times G times height. Right? So all you have to do is to find the individual values and plug it in. So here, I found a real life example of seabirds in New Zealand. Right? If you look at the sooty sheer water, which dives to a depth of 60 meters, which is very, very deep, it has to withstand a certain pressure. What is that pressure? Well, just plug in the values. The density of seawater is 1030, plug that in. G, 9.81, height, 60, find a value of 6.06, 10 to the power 5. That's about 6 times more than atmospheric pressure. Right? So the bird has to be very strong to be able to withstand this pressure. So this is pressure in liquids, right? If you look at pressure in solids, it's also no different from what you have learned in O level. So this is a simple recap. I'm going to go through it quickly. Pressure is just equals to the force, right, divided by the area perpendicular to the force, right? So one of the very common examples is a bed of nails, right, where the magician lies on a bed of nails and come out unharmed. Well, actually, there's a lot of physics there, right? If you imagine a bed of nails with roughly around 5,000 nails, his body is in contact with roughly 5,000 nails, and each nail has roughly 0.07 cm square of surface area, right? The magician has roughly a weight of 60 kg. Calculate the pressure exerted on the magician's skin. Well, all we have to do is take pressure divided by the force. Okay? Pressure equals to the force divided by the area. The force is the weight of the magician, so that's 60 times 9.81. The area that's in contact is 5,000 nails times the individual area. So cm square converted to meters is 0.07 times 10 to the power minus 4. We find that the pressure exerted on the skin is roughly about 1.68 times 10 to the power 4 pascals. I went online and found that the tensile strength of skin is roughly around 20 megapascals, right? So we can then find out and figure out whether the magician is hurt. And as you can see, the value is 10 to the power 4. It's a lot smaller than 10 to the power 6. And obviously then the magician is hurt, right? So thank you very much. We've come to the end of the lesson. If any questions, please feel free to email me or find me, right, at the staff room. Thank you very much. Bye-bye.